So we have a shorthand uh, for using for series, and it is called sigma notation. You've probably seen it before. People like to use it all the time in movies and stuff because it's a pretty advanced idea. I mean, it's one of those things that you need for um, calculus, but it's all based around this Greek letter here. Uh, this is the sigma letter. It looks like a kind of a weird, like an E shape, right? But it's actually this is the Greek version of the letter capital letter S. So that's why we use it for something where we add a bunch of stuff together because it's a sum. Now the positioning on everything is really important. The bottom, uh, we read k equals 1. That's called the index. Um, and that basically just tells you where you're going to start adding things together in whatever series you have. Tells you what the first term is going to be. Usually it's 1, sometimes it's not, sometimes it could be like you could start at the 7th term. Okay. Um, the top, oh man, I can't remember what this one's called off the top of my head. Uh, it's usually some sort of value that's the end. So this is for a finite um, series right now. We're going to have it end. So there's only so many number of terms. And then inside, over here on the right, you have whatever function you happen to be talking about, where the input matches that variable for the index. Um, which is kind of interesting. Uh, Usually we've been using n, but we don't always use n. Basically, if your a sub n equals like 2n minus 1, that was what the formula came out to be, you're going to swap out that n for a k. Um, so let's say I'd start at 1, and I'm going to go to 3. I would have 2k minus 1 here. And basically what this symbol means, it means plug in 1 for k, 2 times k minus 1. That's your first term, plus plug in, you just increase that k value and go to the next term. So now it would be 2 times 2 minus 1. There's my second term. And my third term would be 2 times 3 minus 1. And that sigma notation translates to this um, notation of addition. Now, of course, 2k minus 1 is just a series, so 2 times 2 minus 1 is 1 plus 3 plus 5, which is 8, 9. So this whole thing equals 9. All right, so that's what sigma notation is all about. You can see they did a similar kind of example here in the key concept box, but they went all the way to 12. I wanted to be able to see all of them, so I just did it short. I stopped a lot sooner at something like 3. All right, we're going to use sigma notation. Now, you'll notice a couple things here. We're going to start at k equals 4, and we're going to end at 18. So if I want to know what the partial sum of something is, which is what the same things that the sigma notation does, I need to know how many terms, and I need to know the first and the last terms of the series so I can cut it in half. Well, all I have to do is take my sigma notation, and it will take you some practice and writing that down. 6k minus 1. I'm going to figure out the first couple terms. So I plug 4 in. 6 times 4 is 24, minus 1 is 23. Plus 6 times 5 is 30, minus 1 is 29. 6 times 6 is 36, minus 1 is 35. And that's good enough for now. So next up, it's going to be, I got to figure out what the last term is, so I plug in 18. 6 times 18, ooh, I don't know what that one is. 6 times 18, it's going to be, 112? Let's see here. 6 times 18, 108. Oh, yeah, okay, 108. Minus 1 is 107. Okay, so now I've got my a sub 1 and my last term, but I don't know what the end value is, right? I don't know how many terms there was. Here's what you do. You take the ending of the series and the beginning, and you subtract them. But we're not done yet. We have to add 1 to that. And you might ask, well, why do I add 1? I'll show you in a second here. 18 minus 4 is 14 plus 1 is 15. So now I know my end value is 15. So let's take a thing. What if I just did 1, like it started at 1 and went to 10? Like the questions on a homework assignment, numbers 1 through 10. How many questions would that be? Well, that would be 10 questions, right? That's not hard. But 10 minus 1 doesn't equal 10. So the reason why is when you do 10 minus 1, you're not counting the beginning of where you actually started. So you have to add 1 back into it. So it'd be 10 minus 1 plus 1 for that 1 I start counting at. And it'll get me back to 10. Which means anytime, this is what I do on every homework assignment as well. You know, I assign you 5 through 23. I take 23, I subtract the 5, but I know if I do that, it's not going to give me the 5 that I started counting at, so I add 1 more to it. That's the same thing that's happening here and allows us to find our end value of 15. So that's just kind of a little aside there of what we do. So now I know the partial sum is going to be 15 times 23 plus 107 averaged, which is 15 times, let's see, that's 10, 130 over 2. 130 over 2 is 65 times 15 is 975. And you can say, oh, that's choice C. That's pretty cool though, right? Pretty quickly, I don't even, with the sigma notation, I don't even know what the common difference is, though I could probably guess that it's 6. But I don't really need to know that. I just start plugging in numbers, figure out the first term, the last term, use the indexes to tell me about how many actual terms there are that they're being added together, and that's all I need to figure out the partial sum.